is a difficult question for a question two, and I'm aware that many candidates in the real exam struggled with it. I also went down the wrong path. I went down the kind of the path of labeling an angle and trying to find all the other angles in terms of that and hoping to find something out, but there's not enough information to be able to just use the angles. We have to actually also use sides in this question. So we're given a square and a rhombus, and hopefully you can identify these. And A and E and F are collinear. Find ADE. Okay, so the way to go actually is to just, okay, I'm going to go through this in two ways. I'm going to go through it using non-right angled trigonometry first of all. That's how I did it. But of course, that requires that you've covered that to be able to use it. And then I'll talk about how the answers did it using an equilateral triangle. So my approach was to say that the square has side lengths 1, and then spot that actually the side length of the rhombus is the diagonal of the square. That is absolutely crucial to this question, and that's why you have to go with the side lengths and not just the angles. It's not just any old rhombus in a square, it's the fact that the rhombus has the same side lengths as the diagonal. Because what that means is that that one's root 2, and then I can say that that blue length there is also root 2, because remember it's a rhombus. So if I just draw this triangle in isolation, it's going to look like that. And I've got root 2 up here. But I've got another length, of course, because I've had these red lengths as 1, which means that this length is also 1. Okay, brilliant. And now we want to work out this purple angle. We don't have enough information yet. So we either need to find AE, the bottom side, or we can investigate finding some of the angles. And I'm going to show you how we can go the angle route. This must be 45, and this must be 45 because we have a right-angled isosceles triangle. And then this angle is also 45. But then we see, because we've got a rhombus, that these two lines are parallel, meaning that this angle down here is also 45. We have our right angle from the square, and that means we have this angle here as 135 degrees. Okay, and this is where the sine rule comes in. So I've got an angle side pair. And the sine rule says that you take your angle side pair and sine capital A over A is equal to sine capital B over B and sine capital C over C. But I'm not going to use that one here. That's if you've got A, B, C, and then the opposites are A, B, and C. I'm not going to prove this here. I'm just going to kind of assume that you've done this before. If not, then look at the subsequent solution. So I can write down that sine of 135 over root 2 is equal. Now here's the thing, I don't actually, I've got this angle over here. That's my angle side pair. So I'm going to call this one x. So it's going to equal sine x over 1. Of course, you could label these, I could label this A and little a and B and little b. It's all about the angle side pairs here. Okay, now I did say you need to know a bit about non-right angled trig. You also need to know a bit about exact values of trig and essentially the sine graph, which looks like this. And actually sine 135, which is here, is exactly the same as sine 45, which is here. And sine 45 is 1 over root 2. So we get 1 over root 2 over root 2, that's a half. Sine x is equal to a half. And that means that x is equal to 30 degrees. That, I'm not going to lie, this is a more complicated approach in terms of technicality than the second method, but actually I would argue a little bit easier to see. So x is 30, and then we're done because I can work out the other missing side by adding them up, 165, doing 180 minus 165, which gives us our answer of 15 degrees. Really nice. Right, here's how the solutions expected you to do this question using more fundamental ideas. So I'm going to take a slightly different approach, and I'm this time going to say that the diagonal is 2 in length. That means that, I'm going to do it in red actually, this red length is also 2. Now, if I draw a green line coming down to the corner, then because this is half the diagonal, this green length is 1. And if I then draw another line that's perpendicular to that, and I'll call this y, then this length is also 1. And what I've ended up with is a triangle, this purple triangle, which I'm now going to draw over here away from everything. It has a diagonal length here of 2. This is a right angle by construction. This length is 1. It's actually half of an equilateral triangle. If we reflect it essentially, then we're going to get another 1, we're going to get a 2, an equilateral triangle, which means that this angle here is going to be 30 degrees. So of course you need to write that down and justify it, but that will be 30 degrees. Of course, you could even at this point use trig if you wanted, but hey, we're identifying it as an equilateral triangle. Now the whole angle is 45, which means that angle ADE is going to be 45 minus 30, again giving us an answer of 15 degrees. So 2 methods. This one, more fundamental ideas. It is really nice. This one, a bit more technical, but hey, I also think it's good, my opinion. Anyway, well done on this question.